Welcome back to Explain 4, where we'll be rewriting radical function models. So here we're talking about the surface area of a can versus its volume, and we're given an equation here. So what we're going to do is we're going to use the properties of rational exponents to simplify the expression for the surface area. And then we're going to write the approximate model with a coefficient rounded to the nearest hundredth power. So here we're given our equation, and it's noted in your packet. The first thing we're going to do is distribute that exponent to what is inside. So that would be v is going to get its own 2/3 power, and 2 pi will get its own 2/3 power as well. The next thing we're going to do is group together our pi symbols. So we notice here that we have a 6 pi and a 2 pi raised to another power, but still has a pi itself. So I'm going to write that 2 pi to the 2/3 power with this other pi, 6 pi. I'm going to bring down my v to the 2/3 power. Now we can simplify this out in our calculator to a decimal value, again to the nearest hundredths place. So go ahead and do that if you haven't already. Yeah, go ahead and do that right now. And that would be about 5.5. Alright, so now we have rewritten using our coefficient of 5.5. V now has its own separate space raised to the 2/3 power. Part B of our example does ask us to take this problem, or equation I should say, and instead find what would the surface area be if my volume was 440 centimeters cubed. So I'm going to copy that down. S equals 5.5 V to, I believe, the 2/3 power. Alright, so I will plug in for volume 440 raised to the 2/3 power times 5.5. Go ahead and take some time and work that out on your calculator and find out what the surface area would be. And if you calculated that out, that would be about 318.17. So there you go. Alright, moving right along to part B of Explain 4, just to give you a little bit more practice. Again, here's another problem talking about commercial fishing. So the buoyancy or the floatingness of a fishing float in water depends on the volume of the air it contains. Well, yeah, I mean, try and swim out to sea with a raft or a float with no air. That would not be fun, because you need air in that float to have it stay afloat and survive. But they give us a equation to figure out, given the radius or given the volume of a float, they can tell us our radius. So the first part's asking us to use the properties of roots to rewrite the expression as a product of, again, a coefficient term, so some kind of a number, and the variable term. Alright, so, and again, it's asking us to show our coefficient to the nearest hundredths place. Okay. So again, here's our equation as it's written in your packet. The next thing we're going to do is we're actually going to separate out the number part from the variable part. So here you'll see in this step that they wrote out the number part on its own and the variable part separate. What they're then going to do is essentially, instead of grouping these two things under one cube root, we're going to give each part its own cube root. Alright, so go ahead and use a calculator to figure out what this would be as a coefficient. Remember, we got to round it, and we'll leave this here as the cube root of volume, or V. So take some time, calculate this out. Calculated that out, that would be about 0.62, which can be rewritten as, you can write this as 0.62 3 or cube root of v, or 0.62 v to the 1/3 exponent. It's up to you. Either one's fine. But in part B, we're going to use this newly found equation to work this out. In fact, you'll see that what should the radius be for the float that needs to be 4.4 feet cubed of air to have proper buoyancy. So this would be what we'll put in for our volume. And just to double check our work, make sure that our equation was about right. So we are plugging in instead V for volume of 4.4, and our coefficient was correct, 0.62. Awesome. So again, take some time, calculate this out, and what would the radius be? And the radius would be about 1.01. So that'd be about 1.01 feet. Just like it says here, stop and do the problems in the packet, okay? We'll come back to review the homework and the checkpoint in the next video.